A rogue DHCP server was connected to the network and several PCs received an IP from the rogue device. Implement a solution to ensure this doesn't happen again in the future. Ensure all PCs have a correct and valid IP. The answer to this would be to configure DHCP snooping on ASW4, as that is where the rogue is. Configuring DHCP snooping will prevent this from happening again in the future. In the interest of consistency, and preventing this from happening on any other devices, it would make sense to enable this on all switches, but we will not be doing that in this lab. From the admin PC, log into ASW4. That isn't working. Try to ping it. We are getting a response from the gateway at 10.1.5.1. It is telling us that it is not aware of the destination. Log into DSW1, which is the default gateway, and check the routing table. There is no route to the 10.1.40.0 network, nor is there a default route. Per the diagram, DSW1 should be enabled for OSPF. Check the status of the OSPF neighbors. You could check OSPF interfaces to ensure it is enabled, but I think of it like this. If I check the neighbors and there is one, I know the interface is enabled for OSPF. If no neighbor, then I can verify the interface is enabled. Just a small bit of efficiency. There is one neighbor, and it is in an exchange start state. The exchange start state is the state in which OSPF neighbors decide who will be the master and the sequence number to start. The master simply controls the exchange so that it is orderly and efficient. In your studies, you may have learned that devices remaining in the exchange start state is caused by an MTU mismatch. Check the MTU on interface FA01. The MTU is set to the default of 1500 bytes. Let's log into Core and check its MTU. It looks like we've ended up back in DSW1. Per the diagram, it should be the .2. Checking the interfaces reveals it has been assigned the .1. OSPF neighbors need to be in the same subnet, but as with all devices, the IPs need to be unique. Correct the IP. Return to DSW1 and check the neighbor status. It is still not in full. Clear the OSPF process. Nothing has changed. You could check Core to ensure the MTU is correct, but that isn't necessary for this lab. Recall that all OSPF routers must have a unique router ID. This ID is selected in the following order. From the statically assigned router ID under the router OSPF process, the highest IP on a loopback, followed by the highest IP on other interfaces. Core and DSW1 shared the same IP, and because no ID had been statically assigned, and they don't have loopbacks, both selected the router ID of 10.100.1.1. This is why it is often best to statically assign values instead of allowing the devices to pick them. Correct this by statically assigning the router ID on DSW1, followed by clearing the process. Router ID changes don't take effect until the process is cleared. Check the routing table and see that the network to ASW4 is now present. From the admin PC, log into ASW4. Check interface status to see which interfaces are which. To correctly enable DHCP snooping, you must first enable it globally with the command IP DHCP snooping. You can see here that it is disabled. And now it is enabled. Look here and see that it isn't configured for any VLANs. DHCP snooping must be configured globally and per VLAN. The command is IP DHCP snooping VLAN 40. By default, interfaces are entrusted. This means that DHCP offers and DHCP acknowledgements will not be forwarded when received on these ports. So messages you would expect to receive from the DHCP server are blocked. There is a valid server that the PCs need. Offers and acknowledgements from this server would arrive on interface FA01. This interface needs to be trusted to avoid legitimate DHCP traffic from the DHCP server from being blocked. On interface FA01, issue the command IP DHCP snooping trust. Check the status and it is now trusted. We are almost done. Let's verify the PCs have valid and correct IPs. HR1 still has the IP assigned by the rogue. Request the new IP with the command ipconfig/renew. HR2 is good. Check the activity and it says it's not complete. Think back to the initial issue. The OSPF relationship between DSW1 and Core was not fully established. The PCs on that side would have been unable to get an IP from the legitimate DHCP server. There was no reachability. Sometimes you will resolve an issue, but it is important to always think about other things it may have impacted. You don't want to state you resolved an issue when small traces of it remain. On the remaining PCs, renew the IPs.